Okay, last example for this chapter. The second order maximum produced by a diffraction grating with 560 lines per centimeter is at an angle of 3.1 degree. Okay, so what is the wavelength of the light that illuminates the grating? Okay, so given is n, which is 560 per centimeter, and then we have the angular separation, angular angle of the second order to be equal to 3.1 degree. So n is equal to 2 lah. Okay, so we are gonna apply the equation of diffraction grating. So this is the equation, and we know that the slit separation can be calculated using this equation. So substitute all the values and you will get lambda to be equal to 4.83 times 10 negative 7 meter. Okay, so although I don't actually write the values, make sure in exam you have to substitute lah. So this is 1 over n sine 3.1 degree 2, and then lambda is what you are looking for lah. Okay, all right. And then question B, determine the number of maximums can be observed on a screen. So remember, if it is asking for a maximum, we need to let the angle to be equal to 90 degree. Okay, so use this again. D equal to 1 over n. So we have sine theta n and n lambda. So this is going to be sine 90 degree. This is the maximum number of lines, fringe, sorry. So this is 56, 4.83, 10 negative 7. And then you will get the maximum number of fringes is 36.97, approximately 36. Okay, don't round this off to 37, always round it off to the value yang ini saja. So ignore this one. Okay, so the number of maximum can be observed is 36 times 2 plus 1. Why do we need 2 plus 1? Because we need to include central fringe, central bright fringe. Okay, so maximum is bright fringe. So this is going to be 73 fringes. Okay, and then question C, state and give reason what you would expect to observe if a grating with a larger number of lines per centimeter is used. Okay, so this is asking the relationship. So sine theta is directly proportional to 1 over d. And we know that d is equal to 1 over n. So, when a greater number of lines is used per centimeter, it would result in a much larger diffraction angle. Okay, so larger number of lines per centimeter results in a larger diffraction angle. Hence, the distance between two consecutive maximum fringes will increase lah. Okay, so basically sine theta is directly inversely proportional to the slit separation, and we know that slit separation is equal to 1 over n. Okay, so from here we know that sine theta is directly proportional to the number of lines. Okay, so if this increase, the angle would also increase. Okay.